think about Chioma, this is what I see. That is what drags
kingdom. You put Hala here like church. You know why? Church is the only organized community we have in our
transportation business. I told Harrison, I said, I've already gone far. How many of us know TAP technologies?
Hackathon sessions, because that's how ideas are bettered. It's when you come together and brainstorm.
And my phone number. So you'll be added there. And the point is that any information that comes our way,
Vigilance and startups. You know, before, as a techie, before you can make a wave, before you can make any...
Affected in the general code base, so you can prefix with a hot fix. So this is one of the best practices.
So many of them turn out to volunteer for this event. That will tell you the level of awareness.
The next session is a technical one. We've been hearing about aspire to perspire to acquire your Maguire. Right now, you are going to bring out your laptops and a little technical session. This man, when I saw him, I shouted, Che. Later on, I was like, Che is not the best expression because he don't say. I last saw him in 2014, 9 years ago, in Owerri, Futo to be precise. Put up this thing now. I'm going to put them up now. He will be coming to talk to us about Git. He was the leader then. Now church Holam, if I go SUG, but he was the leader of president of NSCS. If you be NSCS, you go do. Now church president in school. So we're talking about Mr. Solomon Ezeobika, Odinaka. So put your hands together. So now he's a software engineer. I want to call the company that I want to know. Put up the company. So he'll be talking to us about Git. If you know what is Git, raise your hand. If you have heard about it. So we have a fairly technical audience. Okay. I ain't go explain. Maybe we go come they explain. I ain't go explain. Titi it now. I used to wait. Okay, see, just look at. Before I finish reading this thing, is it not for the kingdom to come? Eh? Okay, let me try. Odinaka Chukwu Solomon Ezeobika, popularly known as Solomon. Now your name now, popularly known as is a seasoned full-stack software engineer currently contributing to the innovative projects at Higher Art Incorporated in New York, United States of okay. With over 6 years of experience in the tech industry, Solomon has traversed diverse roles and geographical locations, shaping his journey as a tech professional. Solomon's journey began in tech as a graphics and UI designer, and he later transitioned into a software engineer. His experience includes roles as a full-stack engineer at Andela. You go Andela, you pass. Me, I went to Andela 2 weeks. I didn't survive. I came back to Onitsha. And team lead at Ebenwa in London, UK. And as a back-end engineer at Omise in Thailand. Notably, he led the successful development of the web application for Dimpe Technologies, a Nigerian startup. This groundbreaking application, leveraging QR codes, has revolutionized payment processes. Recognized for its innovation, Dimpe Technologies was selected to participate in Amazon Web Services inaugural FinTech Africa Accelerator Program. Can you put your hands? This page 1, chapter 1 of the book, and the book that series, they covers paragraph 1. All right, give it up for Mr. Solomon Ezeobika.
Protocol. So what I want to talk about is committing to excellence. And our focus will be on Git Essentials for software engineers. Sorry, 1 minute. they talked about the possibility of being globally employable as a software engineer. And of course, most of us might have been operating at the level of the East. But I want to make it known, because I'm a witness. I've worked in several companies in the UK, in Thailand, also in Nigeria, of course, Andela. I worked with Loyster too. And currently I'm working with a company in New York. So I want to let you know that it is possible for you to work from anywhere, even here in the East, in Anambra State. You can work for any company, wherever, worldwide. But there are skills that are very important that will enable one to, be employable at this level. And that is just one of them I want to talk about. So the topic of our discussion today is committing to excellence, Git essentials for software engineers. How many of you have heard about Git? Oh, good. You might have heard about Git. For those who have not heard about it, it's going to be a very good one today, hearing about it, so that you start learning and utilizing it. Then for those who have also heard about it, there are also some aspects of it that are very important, especially the workflow, because it is the workflow that will enable you to contribute efficiently in a distributed engineering team. So let us get going right away. I'm sorry, the slide is not displaying. So we'll be talking about, we'll introduce ourselves to Git. We'll look at some key concepts of Git. We'll look at the installation and setup, talk about some essential commands, Git workflow, and then I'll give you a few tips and best practices. Yeah, sure. I shared it earlier, but we had internet issue for me to grant them access to the. So I think I should have done it before today, but I will still share it later so that you can go through the slides. I also have some recommendations at the end of this session where I shared some links where you can get some resources that will help you to, advance your skill in the use of Git. So let us get going. Let us talk about introduction. Before we talk about Git, we need to understand the history or how it came about, and that is version control, a concept called version control system. So what is version control? In the tech world, version control is simply a system that helps developers to track and manage changes to their source code over time. So let's say you are working on a project. You know that, of course, when we are working on projects, there are several iterations. You have a function, for instance, in a file, and then that is deployed, and the software is being used by user. Over time, there will be need to add some features, remove some features, and all of that. There is need to have a means of tracking these versions. And also in a distributed engineering team, when I say distributed engineering team, I mean a team of engineers where the engineers are resident in several different locations, some in Brazil, like my company, for instance, we have some persons in Brazil, Peru, US, of course, and every other part of the world. And we are able to make changes to our source code, and there is no issue. If you have a file that you've written code and you deploy to a server, users are using it. There are certain changes you can make. It breaks the software. So with the introduction of version control system, it makes it easy for developers to be able to manage versions of their project. And so sorry for the interruption. I'm sorry, since we are having this technical glitch. Okay, yeah. Okay, so let's quickly run through the need for version control. One of them is for collaborative development. So as software engineers, version control system can enable them to work on a project simultaneously. Of course, in different parts of the world, they will make their respective contributions to the code base. Another important need for version control is the ability to maintain a detailed history of code changes. That way, it's different. It is easy for everybody to know the different versions of the code. They can see the history, know what each version added or removed. Another importance is rolling back and recovery. Let's say someone pushes a code, it's been deployed, users are using it, and then with the introduction of a new feature or maybe a removal of one, the code breaks, users are unable to access the application. Because having the history of the software makes it very easy for there to be a rollback. They can reverse and then recover the system in the previous state so that users can continue using the application while whatever error that was introduced will be fixed. Now, let us now talk about Git, having understood the concept of version control system. Git simply is a widely used version control system. There are a number of them, but the most widely used in the industry today is Git. In fact, over 6 years of my practice in this field, I've never seen any other one in use. It's just been Git that I've been using, and of course my other colleagues too. So that is what Git is about. It's just a version control system. It's just a command line tool that will enable developers to, track the changes they make to their code base. So let us look at some key concepts. So certain features about Git include distributed architecture. Just like I mentioned earlier, every developer has a complete copy of the project's history. They can track whatever other persons have made, any other change they have made to the system. Everybody has a copy of it, while the code is resident in a repository in the cloud. Also, another concept about Git is branching and merging. With Git, it makes it very easy for developers to create different branches to add features or perform bug fixes, and then merge the change back into the code base. That way, the software will still be resident in the server, functioning very well, but incremental changes can be made without any issue. And then it's also a commit-based system. What it means is that developers can record their changes through commits. So the commits they make are like the different versions of the software. The changes that they make, it is tracked as a version. But with the concept of Git, it is called commit. And then they can have a detailed and granular history of their software. There is a chart I would have shown to help demonstrate this. It's quite unfortunate that we don't have it displayed. So while I was explaining about the features of Git, there are some terminologies that I mentioned that I would like to explain further, like branch, commit, checkout, merge, log or history, repository, log, L-O-G, L-O-G. Yeah, we have fork though, but I didn't include it because I want to focus on, what will help the developers to work with Git. So we have repository, staging area, pull, push, conflict, and pull request. So among these, there are about 6 of them I didn't mention while I was introducing Git. So let me start with repository. It is just like a virtual container of folders that hold files, documents, and resources related to a particular project. So see it as an imaginary container that holds the project directory, be it files, be it folders, and all of that. There is also another illustration I would have used to explain some of these concepts, like the pull and the push. Then repository could be local or remote. It is local in that the project repository is resident somewhere in the cloud. It is in a server that can be accessed anywhere. And then we have the local state of a repository that is resident in your machine, is resident in your system. So that way, whenever you make any changes, you can push it, and then users will see what you have added to the project. Then another concept is the staging area. So while working on a branch, we have what is called the staging area. It allows you, when you make certain changes, you will kind of push those changes to that area, which is called the staging area, and then you perform review, check to ensure that all the changes you've made are adequate. Once you're satisfied with those changes, you can now add into the next version, and that is the process of committing. You're committing it into the next version. So when you perform that commit, before you now push it to the local repository, and then users can access whatever feature you have added. Then conflict. There are times when developers are working on the same file. So one person makes a change on a line. I wish it was displayed so that you see it better. So an engineer makes an update to a line of code in the file. Another one makes different change in that same file. The system will find it difficult, Git will find it difficult to know which one do you want to retain actually. Is it the one made by the other user, or by the other developer, or the one made by you? That way it flags a kind of conflict. So that is what conflict is about. Then you now take care in resolving such conflict before you perform another commit and then push. Yeah. Then pull request. So when you're done making your commit, you now need to send it to the remote repository. When you send your code to the remote repository, you need to make a request asking that this change you have pushed to the remote repository be added to the entire code base. So the process of creating this request and writing a kind of description that talks about what that change is what we call pull request. Then let us look at installation. When you access the slide, you can see a site. There is a URL that through which you can use to download and then install to your system. It is as simple as clicking the download button that is particular to your operating system, and then you see the installation guidelines. That is it. So it's very easy. Then another thing after installation is that Git needs to identify you to know that you are the one making certain changes and all that. So when you're done installing, the next thing you need to do is to perform a little configuration. And that is, there are commands that you can use to do that. So with that command, Git will use it to identify you whenever you perform a change. Basically, what you're doing is telling Git that my name is this, my email is this. That way, whenever you make any changes, Git can know that you're the one who performed that change. Then let us look at some essential commands. This would have been the practical section where I will do certain things, but unfortunately, we don't have the slide. But when you eventually get it, you see these commands. They are very important. In fact, my entire 6 years of practice, I've been using Git, and these commands are commands that I've been using over time. Like every day of my life, I can wake up, you see that I'm doing it. Every work I do, any change I make, I always use these commands. So they are very important that you know them. We have the basic commands like the initialization, the git init, git status to check the status of your work when you're working locally on your machine. We also have the git add. When you want to add a file, adding a file is just taking it to the staging area, just like I explained before. Then you perform your review. After your review, before you now commit. We also have the command to perform the actual commit. And then we have git log. If you want to view the history, if you want to see every commit each person in the team has made, you use the command git log to get that. We also have git difference. When you want to inspect the difference between the changes you make or any other developer make, you use the command git difference. And then put the two hashes that you want to compare as the argument. Then we also have some methods that will enable branching and merging, like the git branch, the git checkout, and then git branch delete when you want to delete a branch. We also have methods for stashing. You stash when, let's say, you're working on a particular branch, and then you need to switch branch. Git will not allow you to switch branch because you have unsaved changes. So with Git stash, you can kind of save what you're doing and then switch to any other branch. When you're done with what you're doing, you can come back and then apply the stash and continue with your work. So you can see that Git has a lot of commands that will make it very easy for you to manage the changes that you're doing, and also track and see the history of your different commits. Then we also have commands for undoing changes. Let's say there is a mistake in a version that you've committed. You want to change it. There is also a command that will enable you to do that. Then the most important one, which is what enables developers to work in remote teams, are commands that enable working in a distributed environment. Like the clone. Let's say you join a company elsewhere, and then you need to find out the URL of their code base when you are granted permission to their repository, their private repository. Once you get the URL, there is a command that will enable you to clone their code base. You have it in your system and start contributing to their project. We also have the git push command that will enable you to push your branch so that it can undergo review before merging into the entire code base. We also have the git remote for you to check the remote URLs that are attached to that project you're working on locally. We also have git fetch. Let's say other people have pushed their own branches to the repository that is in the cloud. You need to know who has done which and all that. You can use the git fetch to get those new changes and switch those branches. Then we have the git pull for you to pull from the origin. So these commands for working with remote, they are very, very important, because that is what gives you that, that's what gives you that advantage to be able to contribute when you're working in a remote company. Then Git workflow is also essential. To be honest, this needs to be displayed. But then, what I will just try as much as possible to explain it. So, it is important to understand the cycle of commits when you are working. Because if you make a mistake, it can cost the company a lot. That is why you need to understand the concept of Git workflow. In fact, some interviews you might go for, if you want to apply for a foreign job, one of the questions they might ask you is for you to explain Git workflow. Even though different companies, they have their own strategy, they have their own conventions and all of that. But the most important thing is that there is a generic workflow that, as a software engineer who is, who has that skill that it takes to work in a remote company, you need to understand the Git workflow itself. And that is, there is a repository existing in the cloud. You need to have a copy of that repository. And there is always what is called a master branch. There's always what is called a master branch or a main branch. So that master branch or main branch is what holds the code base that is already deployed, that users are using. Now, let's say you want to add a feature. Say we have a page, a login page, and that login page, maybe the button is malfunctioning. Then what you want to do is to fix that button that is malfunctioning. What you need to do is, from that main branch, which is the one resident in the server, you need to use a command to check out to another branch. So when you check out to another branch, that branch, you can call it a bug fix or whatever it is doing. You give it that name. Then perform all your changes, perform any correction, any fix you want to do in that branch. Once you're done with that, you add and then commit. By committing, you've created another version of that code base. And that your version is ahead of what is in the cloud. So when that is completed, you now push and raise a pull request that we talked about before. When you raise the pull request will now be reviewed, checked by other engineers, ensure that there is no issue with it before they can now perform what is called merging. They will now merge it into the code base. Once that is done, it is deployed, and then users will now see the fix that you've done, or if it is a feature that you added, they will now access it. So this Git workflow is the very important aspect of this discussion, especially for those who are already familiar with Git, but this is what is needed for you to perform excellently in a distributed engineering team. So I also would have loved to display the commit cycle, how it goes on your system locally, but I can't do that. So let us talk about some tips and best practices. Some of the mistakes I noticed that some developers do, especially young ones and all that, are, one, when they are naming their branches, because if you want to work on a branch, you have to give it a name that will be used to identify that branch. So one of the mistakes people make is that they don't have a way of, giving a name that helps anybody who sees the branch to know what that branch is about. For instance, it is usually advisable to add something like a prefix. Let's say what you're working on is a feature. You prefix it with feature. If it is a bug fix that you're doing, you can prefix it with a bug fix. And if it is a hot fix, it means that it is something that is urgent, it is critical. It needs to be quickly reviewed and then merged so that whatever fix it does can be effected in the general code base. So you can prefix with a hot fix. So this is one of the best practices in the industry. Another one is commit messages. Some people, when they want to write a commit message, it is very lengthy and all that. Someone may not even have, and sometimes it gets off the key, what exactly that commit is about. So it is recommended that when you are making a commit message, you keep it very clear and concise. You should just precisely describe exactly what that your change is doing. I have two examples. Someone giving a commit message as add validation for user input in login form. This is descriptive, it is descriptive enough. I can say what that particular change is about. But this one, somebody just says update files. Which file did you update? Looking at the name, I don't know what that commit is about. I don't know the change that has been done to the code base. So it's always good that your commit message is very clear enough and concise. Then another one is to always imbibe the habit of pushing atomic commits. Make your commits to be small. It makes it very easy to manage your history and all that. Larger commits makes it very difficult for you to assess or evaluate whatever changes you've made. But if they are very little, it makes it simpler for you to, identify things when they go wrong. Another one is that small changes per PRO is always recommended. So when you are raising a PR, make sure that the particular change that PR is requesting to add to the code base is small. It will help you to even get timely review, and then your change can be added to the code base. Then, just to conclude, Git skill is a very essential one for collaboration and maintaining a well-organized code base. And it is a skill that if you have, trust me, you've gotten very close to getting any job you want to get abroad, because without it, you can't actually work in such an organization. And with this, I wish you a happy branching, committing and merging, even though we didn't get to do some practical works. Then, finally, I have some recommendations. The ProGit book, I have the URL here. And if you happen to meet me after the talk too, I can share it in the group, a version of it. We also have the Atlassian's Git tutorial. We have GitHub Learning Lab. And one VS Code extension I also want to recommend is GitLens. You can install that extension. It will help you to see any code that is written, you can know who exactly performed that change. And that is why when you're configuring Git after installation, you need to provide your email and your username. So GitLens is an extension that will help to mirror those config variables so that you can know who makes such change. Thank you very much.
Okay. Questions? One question. I will do tumbom to Grisi. As the Spirit leads. with face cap. Thank you. When I know verse, so time no day. I know your big intestine and small one, they are now clashing, isn't it?
Good afternoon, sir. So there was this project I was working on with some people recently. So we had 2 local branches, say branch A and branch B. Now we wanted to incorporate some changes from branch A to branch B. Now my question is, how best do you think we handle this kind of issue? Do you think we should merge or rebase or cherry pick? Like just few changes into branch B from branch A.
Just to be sure I got your question, you have a change in branch A, have another one in branch B, and then what you want to do is you want to get the changes in branch B. Some from branch A into branch B. Thank you for this question. This is one of the, if you listen, when I talk about best practices, having small atomic commits. If you maintain this practice, it's rare for you to have that kind of situation. That is why it is encouraged that you have atomic commits. That way, it makes it easy. What you can simply do, you can go to that particular version. You can, if you had maybe smaller, you know at what point the change you need is. You can just get that particular one, create another branch, and then merge into this. And you can only do this if that your branch B is ahead of where you're merging it into. Because if it is not ahead, by the time you merge it, you must have lost some, some resources. So I think that answers your question, right? Okay. So yeah, you can actually, it's something that would have been more practical. But if you have encountered such problem, there are many ways to solve a problem. The most important thing is find out which, by the time you're done with it, it doesn't impact your code base negatively. So just try, what you could try to do at that point is, if you're very sure that the branch B is ahead of branch A, you can, one way I could do this is I can create a different branch that will bring these two together, branch A and branch B. When it brings it together, I make any resolution I want to do, make sure I solve any problem I want. It is okay. Once it is okay, I will bring branch A up to branch C. When I bring branch A up to branch C, you see that branch B has what they both have. I can continue with branch B. I don't know if that makes sense. You have what? I don't think it's a problem. I don't think it's a problem. Another thing is your commit message also makes it easy for you to identify. I don't know if you are getting, your commit message also makes it easy. You can look at the history. If you need to do reversal, you can do git revert. I don't know if that makes sense. So it's just about knowing what your problem is, what you want to achieve, so that you don't make a mistake. And that is why the skill for Git is very, very important. You can go for several interviews. This will just be the question. They ask you certain questions to, assess your level of understanding Git.
All right, let's give it up for Mr. Solomon. As he said, there are many ways to solve that issue. So as he was saying, I now remember there is a command called a cherry pick. Have you heard about it? If you get that book he's referring to, that Pro Git book, you will see list of commands that are available in Git. There is one called cherry pick, cherry-pick. So it's basically copying stuff. So you have like 7 changes in B. You want only 2. You cherry pick the first one. You cherry pick the second one. It's just like you just copy those 2 to your A. That's another kind of solution. Are you clapping? All right, so we have panel of ladies and some gentlemen. These are they are led by Mrs. Happiness Akabike. that lady na fire. If she carry mic like this, you go be like, are we in Death Fest or in Pastor Kumi's Storms on HR? What is happening? So she's very good. And she'll be leading this panel of ladies and gentlemen. I know that there are some men in that panel. So give it up for a co-lead of Google Developer Group, Mrs. Happiness.